Hello, hello, hello! Welcome to Dragon Does Math. We are putting together today what we've learned so far this chapter with adding, subtracting, multiplying, dividing negative numbers, and having to deal a lot with the order of operations when it comes to what do you do if you have negative numbers. So anyways, let's get into it. So we already know the order of operations from the nice little acronym PIMDIS, and my kids know that multiplication and division, in addition and subtraction, are on the same level. So we do parentheses first. This stands for exponents. We won't have any exponents today. Multiplication and division need to be worked left to right. In addition, subtraction after that worked left to right. That is the order of operations. So let's get into it. So the first thing I'm going to look for is parentheses, which I've got some right here. I have some here, but they're just to tell me that that's a negative number. But here there's actually some math getting done. So let's do negative 13 plus negative 4, and let's simplify that. 2 minus 10. Well, 2 minus 10 is negative 8 plus 8. And you scan left to right, no more parentheses besides the negative numbers. Multiplication, I got a multiplication right here. So let's multiply these two together. Negative 4 times negative 8. So a negative times a negative is a positive. 4 times 8 is 32. So this is going to be a 32, and it's positive. Plus a positive, don't have to worry about that. Negative 13 plus 8. Now we're going to work left to right here, and in the past I've split it up, but just to kind of get us used to working left to right, let's go ahead and do, let me rewrite it over here. Let's do that right there. So this is like 32 minus 13. 32 minus 13, well that's 9, isn't it? 19 actually. 19 plus 13 is equal to 32. If you don't believe me, just 9 plus 3 is 2, carry the 1, and yeah. So that is positive 19 plus 8. Add those two together, we get 27. Now you do not have to do it exactly like I do it, but you got to come up with the right answer, and you have to show your work, and this is a great way to do it. Number 2. Scan left to right. There's no parentheses anywhere in, so I see a division problem right there, so let's go ahead and get that one done first. That's negative 32 divided by 4. Since the 32 is negative, I'm going to make sure that the answer remains negative. 32 divided by 4 anyways would be 8, so I have negative 9 minus 8 minus 12. Okay, anytime they're the same sign, we can just add them together, so negative 9 minus 12, that is negative 17. Negative 17 minus 12, that's equal to negative 29. Yay! Alright, scan left to right, see parentheses here. I'm going to go ahead and get that done. 8 minus 12 is negative 4. 5. This is plus here. I don't want to drop that, so I'll put the negative 4 in parentheses. It's a multiplication there. Times negative 4. What's going to hurt you the most here is if you drop something, if you forget to do something. So I just want to make sure I have everything. There's a multiplication here, so I'm going to get that done. There's a negative 5 in front. Negative 4 times negative 4. Well, 4 times 4 is 16. A negative times a negative is a positive. So that becomes positive 16. So we got negative 5 plus 16. That's the same thing as 16 minus 5. If we just reorder that, which is pretty simple, that's 11, isn't it? Alright, so I want you to practice doing those here. And we are on the back now. Boom! Like lightning. Alright. We have to figure out basically the area of this shaded region. So let's talk about Angela's making a paper box. She's using a piece of rectangular paper, and she's cutting it out from it. The rectangular paper, she's cutting out of a 9 by 12 rectangular piece of paper. So since we're already going to have to find area, so let's figure out what it was originally. So Original is equal to 9 times 12. That's 108. So 108 in its inches. So remember, area is squared. So the original size is 108 inches squared. To make the paper box, she cuts out 4 identical rectangles, like this one right here. And the rectangles are shown in the diagram to the right. What is the area that remains after these rectangles are cut off? So we don't know any more information from the paper, but we can figure it out from this, especially right here. It says this is 8. Okay, and that tells us a lot, because remember, the whole thing is 12. The other thing it tells us is this little sign means that this side is the same size as this side. So 8 plus a number twice is equal to the whole thing. So let's think about it like this: 12 minus 8. So say I took away this 8 from this 12, that's 4. And that 4 is split up here, and it's also split up right there. So basically we think about 4 divided by 2, which is 2. So each one of these sides is 2 inches. 2 inches, 2 inches, which makes sense because 2 plus 8 is 10 plus 2 is 12. This side right here, we know this is the whole thing is 9, and this side is 3. So if we did 9 minus 3, which is 6, split it into 2, we would get 3 and 3. 3, 3, 3. 3 plus 3 plus 3 is 9. So that makes sense. So each little, we'll say little rectangle, I'm just going to write little, is a 2 by 3 inch rectangle that we're cutting out. So remember, to find, I should have said this here, to find the area of a rectangle, we just do base times height. So that's going to be 2 times 3, which is 6 inches squared. We also need to realize that there are 4 of these that are cut out from the original one. So total cutout is equal to 6 inches times 4, because there's 4 of them, which is 24 inches squared. So to find what's left, total left, that's going to be the original minus total cut, which is 108 minus 24. And 108 minus 24. 108 minus 24. 8 minus 4 is 4. This is 10 minus 2, really, if you think about it. So 10 minus 2 is 8. So there is 84 inches squared left. And you might be asking, what does this have to do with our equations? I mean, if you really wanted to think about it, this is like 9 times 12 minus parentheses 2 times 3 times 4. You do not have to come up with that, but I just wanted to point out that's where the relevance is coming. This question down here, okay? I just want to read it to you to kind of get you, because I want to say I didn't understand it. I just want to read it to you. Hope to get you started. So Joseph drew a hexagon on a 3-inch square piece of paper. So this means this paper right here is a square. All right, it's a 3 by 3. He cut 4 identical triangles. So each one of these is the exact same from the corners of the paper. The height of each triangle is half the length of the square. So basically, that side of the paper got divided in half. And then the base is divided in 3. Now each side of this is the same, so that is the same as that is the same as that. So think about one number that you could divide. What number plus another number is equal to 3, because it's 3 by 3. What number plus another number? And make sure that it's even, okay? And so that'll give you a triangle like this, where you know the base, you know the height, and remember, a triangle's area is equal to 1/2 base times height. And I'm going to leave it at that. I think you can wrestle with the rest and figure it out. Remember to cut the total that's cut out from the original. And with that, I leave you with only one more statement. M-A-T-H. Good day.